back and we're going to dive straight in and we're going to check how you went with the ones that we asked you to try. So this first one says approximate the correlation coefficient. Okay, this over here is definitely a positive correlation and it looks strong. I would say about 0.9. Okay, now if you say 0.8, that would be okay. But if you go with a negative number, definitely wrong. And if you go with a number closer to 0, also wrong. This one here, I would go with close to 0. Right, now, if I went with 0.9 here, this one's going to be negative because remember it's got a negative slope, so it'll have a negative correlation coefficient. But these are very, very close to being on a perfectly straight line. If this is 0.9, I'm going to go with negative 0.97. Okay, right, much, much stronger. Okay, now you don't have to obviously get these exact, but you do have to get them sort of relatively correct. So for example, if you went with 0.9 here and you went with negative 0.8 here, that would show a lack of understanding because this is actually a stronger relationship, even though it's a decreasing relationship, as kind of what we call a more the less. As the one gets bigger, the other one gets smaller. Okay, indirect or inverse. Okay, so now we are given some data and we asked to investigate whether there's a relationship between this data. So we've got X on the top row, Y on the bottom row. So we're going to bring up our calculator and we're going to put this data into our calculator. So we're going to go mode, 2 for stats, and 2 for our least squares regression line. Now we're going to put in this data, okay, and it's really, really important that we concentrate and do it properly. So 27,4, 26,3, I'm putting in all the X's first. I'm going to pause the video and let you try it, and I'll also put the numbers in. Okay, so there we go. I've put all the data in. Okay, and once we've put all our data in, the 11 data points, I know it seems a strange thing to do. We press all clear. Now it might be saying, oh, where's our data gone? We just go shift stat and we can go 2 to get back to the data. Right, so the data hasn't gone. Okay, now we're going to get our least squares regression line. So we're going to go shift stat 5 for regression. We're going to get our A value, and our A value is 105,11. Right, so Y equals 105,11. Now we're going to get our B value. So we just do exactly the same thing. We're going to go shift stat 5, and this time we're going to go for option 2. You must press equals 2,467. 2,467x. Right, that is our least squares regression line. Okay, now what we're going to do is we're going to work out, we're going to predict the height of a learner with a foot length of 26 centimeters. And just before we even do that, let's look at 26 centimeters. 26 is inside our data set. So this is what we call interpolation. So what we're going to do, we're going to type in the 26. Okay, so just to emphasize, we could just put 26 into this equation for X, but our calculator will do it for us. And the advantage of using the calculator is it's going to use the full accuracy. Then we go shift stat 5 and we go 5 to give us the Y value that goes with 26. And we get 169,3. All right, 169,3. Okay, then next up, we're going to get our mean of our X's and our mean of our Y's. All right, and we can do that from our calculator. Shift stat, we're not going into the regression, we're going into the variables about our data, and let's get the mean of the X's. And it's 26,1545. Okay, 26,155. X bar is 26,155. Okay, let's get what Y bar is. All right, and we're going to get that from the data. So we're going to go shift stat 4 and 5 for Y bar, the average of the Y values, 169,64. 169,64. Okay, now if we put this x value into our equation, all right? In other words, we put it in here, then we should get that value. Now what we're gonna do is we're actually gonna use the calculator to do that. So we're gonna do what we did before. We're gonna go shift stat 4, and we're gonna get the x bar value. Now we're gonna go shift stat 5 and press equals, and there it is, and that's our exact mean of our y values. All right. Okay, so I know you might say, Paul, have we really shown it? If you needed to, you could just write down that you've substituted it in. So in other words, you could go y equals 105,11 plus 2,467 times 26,155, and then say equals 169,64. Right, which is what, as you can see, what our calculator gave us. Okay, then it says let's calculate the correlation coefficient for this data. All right, and remember how we do that? We go shift stat, we go back into our regression menu, shift stat 5, but we choose option 3 for R. Okay, and we get 0.68. R is 0,68. Okay, now what can we say about 0,68? Right, 0,68 is a reasonably strong positive relationship between foot length and height. And just to emphasize, the reason it's a positive relationship, if we had to plot this line, it would go uphill. In other words, as foot length gets bigger, so does height get bigger. Right, so it's got a positive gradient. Okay. Right, we're going to ask you to pause the video and try this next one. While it's paused, I'm going to put all the data in, right? And we're going to see what we get for this one. So this one's about looking for a relationship between learners' performance in mathematics being X and physical science being Y. Right, pause it and have a go. Okay, so there we go. I've put all that data in, and now it asks us for the equation of the least squares regression line. So I'm going to go all clear. I'm going to go shift stat 5 for my regression line, and I'm going to get my A value, and I get 26,7. So y, again, it says to 3 decimal places, so 26,695. Y equals 26,695. That's the y-intercept of my least squares regression line. And then I'm going to go shift stat 5 option 2, which will give me B, and that's 0.370 plus 0,370x. That's my gradient. Okay, so definitely a positive line like that. All right, this is maths on this axis and physical science on this axis. Okay, this says use your least squares regression line to predict for someone who gets 60. All right, so what we're going to do, and notice that 60, if they got 60 for maths, that's inside our data set. All right, our smallest maths item looks to be 46, and our biggest one to be 94. So in other words, all our data is between 46 and 94. 60 is in there, so it's what we call interpolation. It should be reasonably reliable, depending on the strength of the relationship. Okay, we'll look at the strength of the relationship just now, but let's get that number. So we put in 60, and then we go shift stat 5 for regression, and 5 to get the y value for 60. And we get 48.9. All right, 48.9%. That's what we might expect someone to get for science. You'll see the science marks seem to be lower than the maths marks generally. All right, so a friend tells you that he missed the physical science exam, but he scored 35% for mathematics. And he asks you to use your least squared regression line. Okay, now we're asking you, is this a good idea or a bad idea? How reliable might it be? And the essence of this is that 35 is outside here. All right, so we don't know if this pattern is maintained. This may well be unreliable. And the real word that you want to remember and learn to write here is that we are extrapolating. We are extrapolating. And remember what that means. It means we are using a value outside our original data. Okay, then it says calculate the correlation coefficient. Okay, so let's do that. We do use our calculator, shift stat 5, and this time we're going to go for option 3 for R, and we get 0.66. Right. What does that tell us? Okay, and again, 0.66, reasonably strong positive relationship. Okay, notice that the sign of R, positive, and the sign of B, our gradient, are the same. Okay, and what we mean by a positive relationship is that if someone does well in maths, they're likely to do well in science as well. Now we're gonna end off shortly, but we want to show you a couple of sort of sketches, and then we're going to ask you to try the last few questions before we see you next time. Okay, and then that will bring us to the end of this topic. So we're only going to have one more lesson on this topic. It's quite a straightforward, quite a simple topic, but we're going to just quickly show you a couple of sketches now that we hope will help you with your understanding of this. Okay, so the first one we want to show you, and this is just a little online thing where it asks us to guess a correlation. It's just helping us practice. What does that look like? Well, to me, there is a bit of a negative sort of relationship here, but quite a weak one. So I'm going to go with negative 0.1, and let's ask it to show the actual correlation. All right, so it was actually stronger than I thought, which is interesting. All right, let's do a new sample. Okay, this one to me looks quite close to 0, but I may be wrong. Let's try 0. And it's 0.07, so we were very close. Let's try another one. I'm going with a bit bigger than 0. There seems to be a bit of a positive direction, but I might well be wrong, and this is where it gets a little bit. Let's have a look. 0.2. No, in fact, a negative correlation. All right. Okay. This one, I think, is a bit easier. This looks to me like quite a strong, reasonably strong positive correlation. I'm going to go with 0.7. 0.7. Okay, stronger even than I thought. 0.81. Okay, this one, maybe this one's 0.7. This one looks a bit less than. Okay, 0.68. Okay, so these are just to give a sense of correlation coefficients. Okay, if you just Google correlation coefficient, you can, if you've got access to a computer, you can actually practice this. Okay, notice this also allows us to show our line of best fit, but we want to show you another app, and that's this one over here. So here we've got some dots, and we can show the line of best fit. Now you might be saying, yo, look at that line of best fit. Okay, and I'm going to get a correlation coefficient, and the correlation coefficient is 0.88 for those dots. All right, now what I want to show you is that if we remove this red dot is what we call an outlier, all right? Let's just have a look at what we think might happen. Let's look at what we think might happen to the correlation coefficient. Do you agree that if we remove that red dot, our relationship will be stronger? It will go even closer to 1, all right? And let's have a look. It's actually 0.95. And let's look at the line of best fit without the red data point. Okay, and I want you to watch what's happened. It's actually a much better sort of approximation, and the gradients actually decreased. And the reason the gradients decreased is that red dot was actually sort of pulling it up. And remember, the red line is the one with the including the red dot. And so notice if I move that red dot, it goes higher and higher. If I move this red dot closer onto the line, then it becomes less and less of an outlier. All right. Okay, so that's a really important idea. So let's just start again with we can move all these dots around, which is quite nice. So let's do this. Okay, so now have we got a positive or a negative relationship here? That's right, we've actually got a negative relationship. Okay, anyone want to guess the correlation coefficient? I think it's going to be quite strong. Okay, and let's take a look at kind of what it is. Okay, again, if we take the correlation coefficient of all the points, it's going to be weakened by that red point. Okay, it's 0.43. It's not very strong at all. But if we don't include the red point, it's negative 0.31. All right. So that's with the red point excluded. Okay, it's not actually as strong as I thought it might be. And I'll tell you why, because there's some other points here. All right, there's another point over here. So now it's much stronger with that point a whole lot closer. Okay, so now if we show the line of best fit, with the red point it's over there, without the red point it's over there. Okay, so notice that the red point is almost pulling, as the red point moves up, it's almost pulling that line up. Okay, and that's quite an important idea. Okay, so we're going to show you something here, and it's just for interest. But here we've got, it just shows you how a least squares regression line is actually what it does. All right. So here's some data points, and suppose we decide we're going to put in just a line there. All right, and we could adjust the gradient to that line. We might say, okay, well, let's put it. Maybe that's the best place. All right. What a least squares regression line is, each of these points misses this line by a certain amount. Okay, these two are below and these ones are above. If we show squares, and what it does is it shows a square there and a square there. All right, and we work out the area of the squares and we add them all up. All right, you'll see that the sum of the squares is actually, at the moment, it's 20, just about 20. All right, with the line in that position. Now, the reason we square is very much like in standard deviation, where we square to make everything positive. If we didn't square, then this negative discrepancy here would cancel out that positive discrepancy. Now, what I want to show you is that if we go and play with these and say, well, let's move this line up a bit, notice that this is actually a better least squares regression line, because it's actually the total area of all these squares is actually decreasing. Okay, right, and we can play around with this and you can see that it gets better or worse. I'm going to now show the calculated least squares regression line, which is what your calculator would give you. All right, and it's over there, it's 0.57. That line is better. So watch what happens if we drop this, we make this 3.16 about. In other words, I'm going to try and make this the same. All right, notice that the least squares regression line gets to about, the sum of the squares gets to about 17. That's as good as we can get for here. Okay, so that's really just for interest. But the last question that we're going to ask you to look at does actually involve that concept. So we're going to stop there, and we're going to ask you to finish this before the next time, and then we'll go over it with you next time. Have a great day, everyone. Bye now.